Hello students, now we'll be solving 2018 NEET question paper. As we know, there are 45 questions and each carries 4 marks. So let us start one by one. I'll be giving you the applications, how to apply, and if it is a numerical, you will be solving by yourself, and then few I will solve which I need to solve it for you. So number one question, if you see on the screen, is at what temperature will the RMS speed of oxygen molecule becomes just sufficient for escaping from the earth atmosphere? Okay, now for that you need to use the formula. I'll tell you the formula that is from the chapter kinetic theory of gases, and here we have to apply escape velocity also. So simply you will use this formula. So we know velocity v is equals to root over of 3 kBt by m. That is the molecular mass of the oxygen molecule. Okay, if it is an oxygen, yeah, it's an oxygen. Now this is the escape velocity. Escape velocity is constant, which we know already. 3 kb is given in the question, that is Boltzmann constant. M is also given in the question. You need to calculate this value t, right? So I will tell you the answer, you will do it by yourself. Just you need to use the formula. Your right answer will be option number 3. This is the right answer. So I can give a tick on it. Now let us move to the next question, that is question number 2. Number 2, the volume V of a monoatomic gas varies with its temperature T. Remember, monoatomic gas is given. As shown in the graph, the ratio of work done by the gas to the heat absorbed by it when it undergoes a change from state A to state B. What you have to calculate is the ratio of work done by the gas to the heat absorbed. This is also a question from thermodynamics from class 11. How will you do it? You have to calculate the ratio of work done divided by the change in heat. Okay. Now we know change in heat, the small amount of heat can be written as NCPDT. I hope you remember specific heat capacity or molar specific heat capacity. This has already been explained. Cp for monoatomic gas is how much? 5 by 2R dt, right? Now just use this formula in place of work done. Since in the question you can understand that it is for a particular temperature, that means work done according to first law of thermodynamics will be PdV only, divided by dq is this one, n5 by 2 r dt. Now PV equals to nRT, we know that. So in place of this one, nr dt, I can write down dt, divided by n5 by 2 r dt. Now nr get cancel out, dt get cancel out, only 5 by 2 remains, which will be 2 by 5. Now if you see your option, the correct answer will be 2 by 5. So where is 2 by 5? It's in option number 1. So option number 1 is the right answer. Now let us move to the next question, that is question number 3. Question number 3 says the efficiency of an ideal heat engine working between the freezing point and boiling point of water. You know the boiling point of water is 100 degrees Celsius and freezing point is 0 degrees Celsius, right? So what you have to use? You have to use a formula from the chapter thermodynamics again, that is the efficiency of heat engine, which can be calculated as eta is equals to 1 minus T2 divided by T1, right, multiplied with its percentage. Okay, so that percentage will give you what is the T2? T2 is the freezing point, that is how much is the freezing point in Kelvin? 273 Kelvin, and T1 will be 100 degrees Celsius, so 373 Kelvin, right, multiplied with 100. Now if you calculate this one, your answer will come out to be 26.8%. If you want to check, you can do it, the mathematical part. So your right answer is 26.8. This is the correct answer. Now let us move to the next question, that is question number 4. Number 4, it says that the fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe. If the length of the closed organ pipe is 20 centimeter, the length of the open organ pipe is, okay, third harmonic. Remember that it says third harmonic. So how you are going to do it? Here it is. So we know that for a closed one, okay, it will be 3V divided by 4L. It is given already in the question. Also, for open, it will be V divided by the length 2L dash. Now, as it is given that 3V by 4L is equals to V divided by 2L dash. Now see, L dash you need to find out. Others are given to you. This is 20 centimeter, okay, and this VV get cancel out, or V value is also given to you. No, it's not given. So VV you can cancel out directly. So your L dash will be equals to 4L multiplied with divided by, sorry, not multiplied, 3 multiplied with 2. So your L is how much? L is given in the question 20 centimeter. So answer is coming in centimeter. Okay, yeah. 4 into 20 divided by 3 into 2. So 10 times it is 40 divided by 3. 40 divided by 3 is 13.33. So you have to see which option is 13.33. If I go here, 13.33 is this one, 13.2, that means 13.33 you can take approximately as 13.2 only. So the right answer out here is question number 1, right? Now let us move to the next question, that is question number 5. In the question it is given in question number 5, a metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes an angle of 30 degree with the horizontal. Okay, the rod is not allowed to slide down by a flowing current through it when the magnetic field of induction of 0.25 Tesla is acting on it in the vertical direction. The current flowing in the rod to keep it stationary is how much? That is what you have to calculate. It's a good question. It has mixed a concept of mechanics as well as the concept of electromagnetic induction. Okay, so how do you do this one? I will give you the idea. Now if I make a horizontal plane with an angle 30 degree inclined on it, suppose my mass is here somewhat, mg sin theta will act in this direction. If I take the mg to be here, right, and B is the magnetic field. If this is 30, this one will also be 30 degree, right, according to the geometry. And the force due to the current I due to magnetic field induction will be how much? We know F is equals to ILB, right? The magnitude is given by this. So it will be ILB, which component? This component, that means ILB cos of theta. Now this is not moving, that means they are in equilibrium. So at equilibrium, mg sine of theta is equal to ILB cos of theta. Now theta is 30 degree as we all know. So m you know, given in the question, G is also known to you, I is known to you. Oh, sorry, the current I you need to find out. L is given, B is also given. I hope if you use this formula, you can find the answer. The right answer is 11.32 ampere. Please check after solving this, you will get this one only, 11.32 ampere. Now, let us move to the next question. An inductor 20 millihenry, a capacitor 100 microfarad and a resistor 50 ohm are connected in series across a source of EMF V equals to 10 sin 314 t. The power loss in the circuit is, you need to calculate the power. This is from the chapter alternating current. So, which formula we will be using, my dear? So, power is equal to Vrms divided by Z whole square multiplied with R. So, Vrms is equal to V naught by root 2, which we know, and Z, that is the impedance we need to calculate from here, is root over of R square plus 1 omega L minus 1 by omega C of whole square. So, L and C value is given. So, from here you calculate Z. Z will come out to be 56 ohm as for my knowledge. So, if you put value of Z, put Vrm is equals to V naught by root 2, right? Put V naught as your 10 and R is given in the question, that is 50 ohm. Finally, your answer will be from here, your answer will come out to be 0.79 watt. This is the power loss. So, let us see the option. Which option will be the correct answer? Option A is the correct answer, number 6. Now, let us move to the next question, that is question number 7. Current sensitivity of a moving coil galvanometer is 5 division per milliampere and its voltage sensitivity, that is the angular deflection per unit voltage applied, is 20 division per watt. The resistance of the galvanometer is, you need to calculate the current sensitivity I, you need to calculate the voltage sensitivity. Just take the ratio of Is by Vs, that is the current sensitivity and the voltage sensitivity. Your answer will be very easy for you. Just remember that is milliampere, 5 division milliampere, na? So, it will be converted into 10 to the power 3 minus 3. So, finally, the answer which comes out for this option is, for this question is, the solving part is not required, you can do it by yourself only. The right answer is 250 ohm. Now, let us move to the next question, that is question number 8. Question number 8. A thin diamagnetic rod is placed vertically between the poles of an electromagnet. Diamagnetic rod. Fine. When the current in the electromagnet is switched on, then the diamagnetic rod is pushed up out of the horizontal magnetic field. Hence, the rod gains gravitational potential energy. The work required to do this comes from where does the work come? So, if you see, there are options: the current source, the lattice structure of the material of the rod, the magnetic field, the induced electric field due to the changing magnetic field. See, the potential energy gained by the body is directly proportional to the current. So, out here the only answer will be the current source, right. So, I will take the option number 1, which is the correct answer. Now, let us move to the next question, that is question number 9. Question number 9, it says that in the circuit shown in the figure, the input voltage Vi is 20 volt, where VBE, base emitter voltage, is 0 and collector emitter voltage is also 0. The values of IB, IC and beta, that is the amplification factor, are given by, which we have to calculate. Okay. In the question, it is saying that, please keep that in mind, it is showing that this portion VBE is equals to 0, and also it is saying that VCE, this one VCE is also equals to 0. Now, you need to calculate IB, IC and you need to calculate beta. How do you do that? So, first you go for the input section. In input section, Vi is equal to VBE, that is the input voltage, plus IB into RB. So, input voltage is given in the question itself. right? It is 20 volt and VB is 0, this is 20 volt, and IB you need to calculate. For that RB to be known, RB we know that it is 500 kilo ohm. So RB is given to us 500 10 to the power 3 ohm. So all the quantities are known to you except IB. I hope you can find out IB from here. Similarly, if you go to the output circuit, in output circuit you need to calculate IC. What you will do? V out will be equal to VCE plus IC into RC. Again, VC is given in the question to be 0 and V out is already given out here is 20 volt. So this one will be 20, and RC is also given in the question, that means 4 kilo ohm, that means 4 to the power 3 ohm. So from here you can calculate IC also, right? Last but not the least, you need to find out beta. What is beta? That is the output current divided by the input current. Now output is IC divided by input is IB. Remember, we have already finished calculating IC, calculating IB, so beta will be known to you very easily. From here, if you calculate, the correct answer will come out to be number 4. So I can click on number 4. Question number 10. In the combination of the following gates, the output Y can be written in terms of input A and B as shown in the figure. This is a topic from the chapter Semiconductor Physics, class 12. How do you solve this one? Let us see. Okay. This is a NOT gate, this is AND gate, and the last one is connected as OR gate. We need to calculate Y. Okay. Now A is going here and B is connected to NOT gate. That means out here B bar will go. So in here the output will be A dot B bar, right? So again you see this AND gate, B is going here, and from here A bar came, so out here the output will be A bar dot B bar, sorry, A bar dot B. Now finally it is connected to an OR gate. OR gate is the addition of the inputs. Now the input will be A dot B bar plus addition A bar dot B. So this is your answer. Now search in the option which one is the correct answer. Option number 3 is the correct answer. This is how we can get the answer for question number 10. Now let us move to the next question, that is question number 11. In a PN junction diode, change in temperature due to heating. If you change the temperature in a PN junction, both the thing will change, that is forward bias as well as the reverse bias will change. This is also from the chapter what? Semiconductor Physics. Option number A, affects only the reverse resistance. No. Does not affect resistance of PN junction. False. Affect only forward resistance. False. Affect the overall VI characteristics of PN junction. This is the correct answer. Option number 4. Overall VI means both forward bias and reverse bias will be affected. So option number 4 is the correct answer. So you can click on option number. Now let us go to the next question, that is question number 12. Question number 12 says, unpolarized light is incident from air on a plane surface of material of refractive index mu. At a particular angle of incidence, it is found that the reflected and the refracted ray are perpendicular to each other. Which of the following option is correct for the situation? Now let us draw the diagram for this one. This is from the chapter Wave Optics, if you remember, the Brewster law. If you see, if I have two medium of refractive index, this is N1 and maybe this is the denser medium N2, a light ray is incident. Unpolarized means both the vector will be there, electric field vector and magnetic field vector. Okay, so this is my angle of incidence. So light will get refracted and few of its vibration will be reflected back. So this angle out here is 90 degree. Fine. So this is the point of vibration which magnetic field vector will go and electric field vector will come in that way. So if you look at the option, which will be the correct answer, let us see. Option number 1, the reflected ray is polarized with its electric field vector parallel to the plane of incidence. No, it's not parallel, it's perpendicular. I is equals to sine inverse 1 by mu. No. Number 3, reflected light is polarized with its electric field vector perpendicular to the plane of incidence. Number 3 is the correct answer. As we have seen, it is perpendicular. So I can click on number 3.